So question 12 in chapter 8 has to do with partial pressures adding up to give you a total pressure. So first, to really grasp this, I think it'd be easiest through an illustration. And let's take this balloon here. So that's what that is. So I'm going to erase that. We need that explanation. I'm just going to take this balloon and I'm going to put it to, connect it to an air tank that contains helium. And then you turn on the air tank, and then the balloon blows up. So now there's a certain pressure inside the balloon, that makes it blow up. And the pressure inside that balloon, let's say that it is, for example, 75 torr. 75 torr, that's the pressure inside the balloon, that's making it expand. Every time the gas molecules smack against the inside of the balloon, they exert pressure on it that's making it blow up. Okay, now let's take that balloon off of that particular gas container and put it onto another container. So now it has some helium in it that's exerting 75 torr, but we're going to put it onto this oxygen container and blow it up again. We'll put more gas into the balloon. So you turn the valve open and it'll and the balloon will open up even more, blow up even more. And so now you're adding even more pressure. There's the pressure that's already there from the helium you put in the balloon, but now there's even more pressure coming from the oxygen. So let's say that the pressure from the oxygen is just, 425 torr. Torr is a unit for pressure that really is the same thing as millimeters of mercury. Anytime you see torr, you could just erase it and write in millimeters of mercury, mmHg, millimeters of mercury. Okay, so now our total pressure is the combined pressure from both of these two. Okay, but let's say we took this balloon yet again and brought it to a third pump, a third gas container, this one for nitrogen. And then we open the valve, and now nitrogen gas blows in. So there's already the pressure there from helium and from oxygen. Now it's also there from nitrogen. And suppose we didn't know the pressure from nitrogen, but we know that it exerts some pressure because the balloon blew up. We just don't know how much. Okay, now if you did know the total pressure in the balloon, let's say we knew the total pressure was 925 torr, you could figure out the pressure that's due to nitrogen, because you know that all of these partial pressures, each of the gases contributing a certain amount of pressure, so each is only part of the total pressure, so they're called partial pressures. We know that each of these partial pressures have to add up to the total pressure. So we can make a little algebraic equation, and we can say 75 torr plus 425 torr plus x equals 925. And if you do that, you can solve that little algebraic equation. So the first thing you'd want to do is to add up 75 torr and 425 torr. So those two together would equal 500 torr. So you'd have 500 torr plus x equals 925 torr, and then you could just subtract the 500 from both sides. So you could say, okay, minus 500, it would cancel on the left, and you would have x equals 425 torr. So that's the amount of pressure that nitrogen must have been exerting in order to add up to that. And that is what exercise 12 is asking you. It says a gas mixture containing oxygen, so that was our purple, nitrogen, that was our green gas container, and helium, that was our light blue gas container, exerts a total pressure of 925 torr. That's the total pressure. If the partial pressures, right, because all of the gases are exerting pressure, the pressure from just one gas is not the whole pressure, it's just part, so it's called a partial pressure. For oxygen, are 425 torr, that's what we plugged in, and 75 torr for helium, that's what we plugged in. Then, what is the partial pressure in torr of the nitrogen? And that's what we solved for. For the partial pressure of nitrogen, it would have to be 425 torr. So the big concept to get out of this problem, and sort of the general abstract way of talking about what we did, you can summarize all this with a haiku equation. Equations are the haiku of chemistry. They summarize all these relationships. So you could take the pressure from one gas and add it to the pressure of a second gas and add it to the pressure of a third gas and so on, and you would get the total pressure. So this is the equation that we really thought through and derived ourselves in this problem. And you can use this equation to solve for any of these variables if you have all of the others. So in this one, we had 1, 2 in the total, so we could solve for 3. So the partial pressures add up to the total pressure, and you can use that to find relationships between them.